So hey everyone, welcome to my talk, and my name is Sida. So I have my co-presenter Rob here. Rob, do you want to introduce yourself?
I'm Rob. I'm on the same team. We work together on animations and animation-related code, and we're working on compositing more properties.
Yes. So yeah, today my topic is compositing more animated properties. So I'm going to talk about an ongoing project that try to accelerate more kinds of animations by moving it to the compositor thread. And throughout this talk, I will use background color as an example to demonstrate how this project works. Background color is one of the most animated properties. From the Chrome status page, I have a link here from the Chrome status page. It shows that about 22% of the page load that animates background color. So when we compare an animation that is running on the compositor thread versus animation that is running on the main thread, we know that usually the compositor thread animation is much smoother. That's the case. We actually have a histogram to capture the percentage of the frames that gets dropped, and then the histogram shows that at 50th percentile, a main thread animation typically drops about 35% of frames, while the compositor animation would drop about 1%. Now here, drop means that a frame either means it is that deadline, or it is presentation deadline, or it just never present on screen. Here, this diagram just shows that what is a typical main thread animation pipeline. So for a main thread animation, for example, background color animation, the first step is that the main thread animation system kicks in. It calculates what is supposed to be the current color. For example, animating from black to white, it calculates a color, give that color to the paint system. The paint system will then generate a bunch of draw commands, and then give those draw commands to the compositor thread while commit process. And when it comes to the compositor thread, the compositor thread will rasterize and then give commands to GPU. Then GPU will show the color on the screen. And that is really high level overview of the pipeline of the main thread animation. Now let's take a look at the design of our project, and we'll look at each step of the pipeline. The first step is the main thread animation system. At this step, really we don't do anything, specifically for our case, because we are gonna composite animation, basically sending animation to the compositor thread. So at this step, there's nothing we need to do. Okay, when it comes to the paint stage, so paint stage, it just gets confused, like this confused cat. It doesn't know what to do because the main thread animation just sends nothing to it. So what's the color? It doesn't know. Well, we will tell the paint system to paint a placeholder, so no color in it. It doesn't need to paint any color at this moment. We already have an existing infrastructure to support this. It's basically an image that contains no color information and saying that just wait, the compositor thread will fill the color in, so don't worry about it. Well, the paint system still needs to do something. So it sent some necessary information to the compositor so that later the compositor can fill in the color. The information includes the size of the element and also the start and end color of the animation. For example, say that we start animating from red to green, then the start color will be red, the end color will be green. This next step doesn't really belong to the paint step, but it actually is the next step that we need to create an animation and then send that animation to the compositor. Well, here, we don't create a color animation. Now, we create a 0 to 1 progress animation. And you may be asking, well, this is animating background color. Why do we create a 0 to 1 progress animation? Just hold on for that, and we'll answer this question in about 2 slides. Okay, so now we get to the compositor animation system. Well, the compositor animation is a 0 to 1 progress animation that we received by Blink from the main thread. And the compositor thread will take that animation. It's a 0 to 1 progress animation. So we again, CC already has the infrastructure to support this. After all, we are just animating a number. It's a float number from 0 to 1. So it's very simple to implement. Actually, in fact, we just need to add maybe 10 lines or maybe less lines of code to support this. And another cool part of it is that the same kind of animation can be used for other kinds of properties. For example, if we want to animate clip path, we'll use the same kind of animation. And also, by this design, we don't have to convert Blink types to CC types that CC can understand, and then convert it back to Blink types so that it can paint. Okay, finally, when it comes to the compositor raster, this is the step that we need to fill in the color. So this is pretty much the most important part. So we will grab the current progress of the animation, and then current progress is produced by the compositor animation. It takes animation, it produces the current progress. And remember that the paint system, previously in the paint stage, it sent some kind of data structure to the compositor thread, and that contains the start and end value of the animation. So put these things together, we can compute the current color. And the cool part of this is that we use the Blink's interpolation code to compute the current color. And that's really, really the cool part of this design, that we don't have to write new interpolation logic in CC to compute the current color. Instead, Blink has the interpolation code for background color, and for also for other types of property like clip path. We can just reuse the Blink's interpolation code. So remember that we also mentioned that we create 0 to 1 progress animation, and that's because one, CC can already support that 0 to 1 progress animation, and two, we can just use the progress and use the Blink's interpolation code, and this kind of design will fit in all the future property that we want to support, because it can be easily extended. So again, this is a simple diagram to show the process of the design. Suppose we are animating. So suppose this small element here, it has background color. We want to animate from red to green. So the paint stage will just pass this set of things to the compositor, which contains the size, which say 100 by 100 pixels, the start value of animation, which is red, the end value of the animation, which is green, and it also needs to pass a 0 to 1 progress animation to the compositor. The compositor animation takes it, calculate the current progress, say 0.2. We use Blink's existing code to compute the current color and get this. Then compositor raster will get a color, and then GPU will show this color on screen. Okay, so this is a demo. I have the link to the prototype. I uploaded to the Garage. It's a prototype, so keep in mind it's a prototype. It's hacky, but I promise that when I land code, it's gonna be good. Okay, this is the demo. I hope you can see it, and on GVC that the left, it's both animating red green, and I hope you can see that the left one is smooth and the right one is janky. So what happens is that the left one, I just use a CSS animation. So with our design, it's going to run on the compositor thread. On the right hand side, I did it in the JavaScript. I fetch the current color of the left element and assigned to the current color, to the background color of the second element. That's all done in JavaScript, and I also inject some artificial jank in JavaScript. So that way, it kind of emulate a background color animation on the main thread, and you should be able to see that if GVC isn't really good enough, you can look at the slide. I have shared the slide in the schedule. You can take a look at this, and then obviously the left one is much smoother than the right hand side one. Okay, that's the demo. Rob, do you want to present?
Yeah, I'll take over the presentation. But first, for a moment, let me just explain too. This is built on the off-thread paint worklet code. So it's using this path where, based on this image, we can invalidate the tiles on the compositor. So we don't need to create a layer. And then we repaint on the GPU and do that compositor's impulse side invalidation. So all of this, produces no additional composited layers. We're just redrawing tiles on existing layers. And it could have arbitrarily complex content within it. Anyways,
go ahead.
On to the next slide. Sorry. Okay, I'll do it.
Okay.
Present, tab. That good? Yep. So in terms of properties we can support, we can do this for any property that doesn't affect layout and that can be painted without knowledge of the contents. So on the first point, if the property changes the way that the content lays out, we wouldn't be able to produce an image that would correspond to that without replicating all of the Blink layout code. The same is sort of true of the second argument as well, where say you're animating something like color, that needs to specifically paint all of the font glyphs that are affected by that color change. And that would be a fairly large data structure to transfer over to the compositor side. So that is a hard property to support. But we can do things like clip path, box shadow, and I thought I'd show a few demos of this. So if we do this, here's an example demo where when you hover over this element, we do a clip path animation. And so you can do these like square to circle animations. You can have a fancy reveal instead, such as this nice expanding menu. And then background position is commonly used as well for things like doing a parallax background effect, where different background images are moving at different speeds or maybe moving in proportion to the scroll. Box shadow is a particularly interesting one because you can do a bunch of button animations, including making it look like buttons lift off of the page by having, say, a growing shadow. And because with all of these effects, there's no impact on layout, and it's just based on the elements layout box, we can do this painting on the compositor. So similarly, we could also do things like border color, outlines. Sorry, nothing else comes to mind immediately, but so all these demos are linked from the slides. And we have a design document talking about how this is built, and open it up for questions.
Sam?
Is there a set of properties that you can't do this for because they affect like composition decisions?
So this isn't actually changing the composition. This is, there may be properties which affect layering, which would mean that we couldn't do this, but like when we do this background color animation, we're not producing a new layer. We're inserting an image whose draw instructions are filled in on the compositor side. And so this is the same as, say, image invalidation happens on the compositor, or for animated GIFs or paint worklet. So it may be difficult to do if there's not a clear layer at which that image can be inserted, but it doesn't actually promote elements.
Yeah, I was thinking of things that might like expand layer bounds or something like that as a result of the animation. Not actually change layer choices, I suppose. Even though once you take squashing into consideration, maybe that also is a possibility.
So that should be fine. There may be some complexity around calculating the maximum layer bounds when we initially create the layer, but in theory, that there should be no reason that we can't support those.
So for the box shadow example, the one where you said it simulates making it look like it's rising above the page.
Yeah.
In that one, why does it move the element up? Wouldn't that affect layout? Wouldn't that indicate?
That was a transform.
Oh, that was a transform and the box shadow at the same time.
Yeah.
If it was just box shadow, it would just start to.
Right. But it's common to have like a button that looks like it lifts off of the page with a transform and a growing box shadow.
Makes sense. Cool. It's a neat animation.
And yeah, as Sita mentioned, the huge advantage here is that we don't have to build a like new CC type for each new property we want to support. We're generating the paint instructions in Blink, and we're doing the painting in Blink. So all the compositor needs to know is that you're doing an animation.
Yeah. So as a matter of fact, that the prototype that makes the animation work, like it cost me maybe roughly 4 hours. That's pretty much it.
Ian, I think your question is related to what Sam was asking about. If the animation was composited, like meaning a different texture, then you need to allocate a texture buffer large enough for the thing at the largest shadow rect. Otherwise, you would need to just expand the raster invalidation rect to cover whatever it is you are invalidating. But I think otherwise, just replaying the display lists on the appropriate rect would just work.
Alex?
This is great. Composited accelerated clip path drawing has been a huge request by lots of creative types. I'm not one, but I know they're into it. When can we have it? This is so good.
Thanks.
Yeah, I'm really looking forward to seeing the effects that people build with this.
Well, when the question there was, when can we have it? Do you have an idea for a timeline for this?
Oh, we're expecting Q1, like mid Q1, roughly.
So I believe that my goal is to make this make it work behind a flag by the end of Q4, and then enable it at Q1.
This would be for background color first, right? So
Background, yes.
Yeah. Clip path shouldn't be significantly more complex, so we should be able to get that done in Q1 as well, but that may not be mid Q1.
Cool. I apologize if this question was already raised or point made earlier in the presentation, but did you go through the observed percentages of what's being animated on the web today and how it would impact?
Yeah.
I just think it's good to point that out, that's all.
Background color, so from Chrome status, background color is 22%, which is just right below opacity and transform. Clip path isn't that much, but it might be due to that people use workaround to avoid repaint on every frame to achieve the same kind of effect as clip path. So
this is from Chrome status, the list of animated properties in CSS and web animations. And yeah, so as we were mentioning, background color is the third most popular animation, whereas clip path is not animated on very many pages today, but we are hopeful that making this fast will unlock developers using this.
Yes.
Because we know that many developers want to do these animations. They can be really nice looking, and yeah, it's going to give a lot of capability.
You had asked a question on the chat about blacklisting composition types.
I don't think we need to change any compositing decisions in this case. Specifically, we are not adding new layers in this case. I'm not sure if that answers the question.
Yeah, I think at a high level, it's important to understand that developers need to do absolutely nothing to interact with this new system. They just get this one for free,
yeah.
And that we promise to implement the exact same frame by frame, or at least as good as, hopefully better, delivery of the same animations. This is not intended as a user-facing feature, but as a back-end optimization.
I think my question is like, how are we gonna decide whether we should, we don't composite with animation, but we can composite a background color animation?
Well, so we actually require a specific implementation of a native Paint Worklet painter for each supported animation property, because we need to know how to paint it.
Yes.
So width will not be one of those.
Okay, I see. So it's kind of like allow listing.
Yes.
Right. Okay. Thanks.
Also, you'll be able to save GPU memory by not compositing opacity pretty easily, right? And still getting the threading benefits.
Yeah, I mean, that's a related project to modify, say, opacity or transform, and then do the necessary invalidations without compositing an element. But
yeah,
it's not exactly the same infrastructure, because this is about like inserting an image where we paint arbitrary contents into the display list.
Yeah, that makes sense.
I think my question plays off of that one, perhaps. I was curious if you're doing something like scrolling and somebody writes a web page that loads down this system with a whole ton of animations. How do we figure out like what wins in terms of priority if we can't do it all in time?
I mean, we have this, the main thread is already suffering from this issue, right? Where we can't do everything in time. And it's already the case that you can composite a bunch of animations and slow down the compositor. So like, I think we will need to start looking at some of these cases and figure out what reasonable thresholds are, or how we can dynamically change how many composited layers we have. But this isn't a new problem. This is building on the existing infrastructure.
Yeah, I think the difference is this I mean, outside of what Paint Worklet can already do, this adds that problem to the compositor, though, right? Outside of the main thread can, of course, set up so many layers the compositor can't process it all in time. But now we're adding additional work in the compositor that can also cause the compositor to bog down. I was just wondering if we were considering like a tier of priorities, like this work is considered most like highest priority and has to get out, even if the rest of the work has to be delayed till the next update. That
Right.
sort of a thing. Or is this kind of a TBD, to be determined?
So this causes invalidations in the pending tree. So it will actually have a lower priority than, say, scrolling or transform animations, because we'll produce this new tree, and then until we actually produce the tiles for it, we'll continue to show you the previous active tree. Whether or not that's desired, we can debate, but that is naively how it will take effect, which is sort of similar to how Paint Worklet works.
Okay, cool. Thanks.
I think we're running out of time anyway, so if there's no more questions, we can.
Rahul has one in chat.
Oh. Right, so the plumbing to know about which tiles are invalidated already existed for Paint Worklet. And this is actually building on that. So we are effectively just saying, hey, we're invalidating this Paint Worklet image, and we have already built the infrastructure to know which tiles include that Paint Worklet image in the tile. And then it can go and invalidate all of those tiles and produce the new frame.
Oh, cool. That makes sense. Thanks.
Right. Thanks, everyone.